Alright, good morning math topics. Seniors, today's the last lesson of math I'm going to teach you in your high school career. I know that is terribly sad and you're all distraught, but we're going to get through this thing, alright? So today's focus is on applying what we learned last week, which was the law of sines and the law of cosines, and then also using the bearing information that we learned earlier this week. So it's just solving word problems that involve triangles, and this stuff's very applicable. If we were at school, it'd be really fun to go outside with our phones and use bearings and walk around and solve problems, but sadly you're stuck at home. So here's some scenarios in which this type of stuff is applicable. Two hotshot fire lookout stations are 20 miles apart. Hotshots, you guys, are just wildland firefighters, pretty elite crew, people that they drop into fire zones with parachutes and stuff. Buddy of mine's a hotshot actually in the Pacific Northwest. Anyway, so the two stations are 20 miles apart from each other. And Station B is directly to the east of Station A. So that's why when I drew my little bearing compass rose here, you can see that Station B is on a bearing of 90 degrees from Station A, because 90 degrees is due east. All right? Both stations spot a fire on the mountain somewhat to the north of them. So here's some firefighter standing on Station A. He kind of looks to the northeast and sees a fire. Some firefighter standing on Station B. He looks to the northwest and he spots the fire. All right. The bearing from Station A to the fire is 50 degrees. All right. So recall, a bearing, you always start at 0. So the bearing from Station A to the fire is 50 degrees. So what's happening here is that you have some firefighter, he's looking out with his binoculars, looking due north, and he turns 50 degrees clockwise, and bam, he sees that fire. So this angle that he has looked is a 50-degree angle from here to here. That's that bearing of 50 degrees from 0 north. All right? The bearing from Station B to the fire is 324 degrees. Okay, so remember, same deal. All right, now, this guy's standing here, he's looking due north at 0 degrees, and the bearing is 324 degrees. So there's two ways you could think about this guy. All right? He could have been standing here inside of his little fire station, and he could have been facing north and then started to turn around. Now he's facing east, now he's facing south 180 degrees, west 270, and then he would go for 324 degrees, he's going to go 54 degrees past 270 to look at that fire. Now I know that does not make a whole lot of sense. All right? No one's going to do like a full 360-degree turn to spot that fire. So rather, another and easier way to think about it is if he is staring due north and he looks at a bearing of 324 degrees, well, due north would be 0 degrees or 360 degrees, right? If you rotate all the way around, it'd be 360. Well, how shy of 360 is he looking? Well, 324 degrees is 36 degrees shy of 360. So he's making a rotation counterclockwise 36 degrees to get to that bearing of 324. So I know that this angle will be 36. And the other way you can think about it is this is 90, this is 180, this is 270. Well, how many more degrees does he need to look past 270 to get to 324? Well, 324 minus 270 degrees gives me 54 degrees. So this would be 54 degrees. All right? So a couple different ways you can think about it, you guys. Remember, if you're going clockwise, you're starting at 0, 90, 180, 270, and 54 degrees past 270 gives you that bearing of 324. Or all the way around is 360, and 36 degrees before 360, or 360 minus 36 would give me that bearing of 324 degrees as well. All right? So it doesn't really matter how you think about it. You just got to figure out what these angles are. All right? The other thing to note is that in this part of the problem, if this bearing is 50 degrees and the north axis and the east axis make 90, that leaves 40 degrees right here. All right? So this is what it's asking you to do for part A. When it says to draw a picture, you guys, to make things easier on you, I'll give you little diagrams, and essentially all I want you to do is to fill in side lengths and angle measures. Okay, so that's part A. We were able to apply what we know about bearings to determine that this angle inside the triangle is 40 degrees, this angle inside the triangle is 54 degrees, and the two stations were given 20 miles apart. Alright, so the next thing is to actually use the law of sines to determine how far the fire is from each station. Alright, so here's what I knew about this triangle. I knew that this was 40 degrees, I knew this was 54 degrees, and I knew it was 20 miles between. So 40 degrees, 54 degrees, and 20 miles between. Use the law of sines to determine how far the fire is from each station. So let's call the distance from station A to the fire X, and from station B to the fire Y. Alright, so remember the law of sines says in order to do it you need to know an angle and the side across. So let's just look at all those pairs of angles and sides across that I have. I know this angle and the side across from it. I know this angle of 40. I'm going to find the side across from it. And then I would need to know this angle and the side across from it to be able to solve this problem, which I do know because of the triangle sum theorem. 40 and 54 is 94, which leaves 86 degrees for this angle right here. So now I've got everything that I need, and I can now solve for what's missing. So here we go. Let's do the math, and we'll go from there. All right. So first, law of sines. All right. So I know that the sine of 86 over 20, sine of 86 degrees over 20, so this sine of this angle over the side across from it has to equal the sine of 54 over x. Alright, and now we're just going to cross multiply and we'll solve for what's missing. So here we go. Let's see, let me get out my calculator here. Well, let me first set this up. So when I cross multiply, I'm going to get x times the sine of 86 is equal to 20 times the sine of 54. To solve for x, I will divide both sides by the sine of 86. Bam. So x equals. Now we'll take out the calculator and we'll just punch that in. So I got 20 times the sine of 54. Make sure you close your parenthesis on that 54. And then I divide it by the sine of 86. And I get that x is about 16.2. So yeah, around 16.2 miles. And what that represents is the distance from station A. All right? From station A to the fire is about 16.2 miles. All right, and then we'll find the distance from station B. I called that y. All right, so I'm going to use the given information from the beginning that I know. I know that the sine of 86 degrees over 20 has to equal the sine of 40 over y. So when I cross multiply this, I end up with y times the sine of 86 degrees is equal to 20 times the sine of 40 degrees. Then, so it's cross multiplied. Then I'm going to divide both sides by the sine of 86 degrees. And I get that y is equal to, bust out the calculator again, so I have 20 times the sine of 40, closing that parenthesis after the 40, and then dividing again by the sine of 86. So in this case, I found y, the distance that fire is about 12.9 miles roughly. And that was the distance from station B. There you go. And the very first problem in your homework assignment, or your daily assignment today, is going to be a problem just like this, the same scenario. It's going to give you the same information in a different context, ask you to find the angles, and then use those angles and the law of sines to figure out what the side lengths are. All right, next problem. All right, so what we have here is new scenario. This time, what's given to me is not the bearings, we're going to actually find the bearings. This time what's given to me is the distance between some spots or islands in this case, or the sides of a triangle. So the picture below shows 3 islands and 1,000 islands. It's a group of 18, oops, that's supposed to be 18,000. I don't know what happened there. 18,000 islands of the St. Lawrence River between U.S. and Canada. Okay? Actually, this is where the name of the disgusting salad dressing comes from, FYI. Alright, so the first thing it says to do is to use the law of cosines to find the measure of angle A. So this is what we want to find. Now, for law of cosines, alright, and I'll tell you in your assignment exactly what to use as well. Remember, here's what you need. You need side, angle, side, to find that third side over there. So, in terms of law of cosines, actually, let me change this. Alright, the law of cosines is this. C squared equals A squared plus B squared minus 2AB times the cosine of C. So, actually, let's call this big C, little a, little b. Because remember, when you're applying the law of cosines, all of the stuff that's in this little side angle side situation, so you have the angle you're looking for and the 2 sides next to it, that always goes in for A and B, and the angle you want, and then the little loner side over here, that goes in for C. Alright, so in using my law of cosines, I'm going to plug in for C. This would be 7 squared equals A is 5 squared plus B is 6 squared minus 2 times 5 times 6 times the cosine of C. And remember, the objective here is to try to get this by itself so I can solve for C. So now I have to do a little simplification in my calculator. So 7 squared is 49. That's 25 plus 36 minus 2 times 10, or excuse me, 2 times 5 is 10, times 6 is 60, times the cosine of C. Alright, so that's 49 is equal to 25 and 36. What does that give me? 61. Alright, minus 60 cosine C. And I want to point out to you again the common mistake that always happens. We're trying to get cosine of C by itself. You cannot do 60 minus 61 because this 60 is being multiplied by the cosine of C. So what we need to do is we're going to subtract 61 from both sides first. Alright, when I subtract 61 from both sides, I get negative 12 is equal to negative 60 cosine C. So in order to get the cosine part by itself, which is exactly what I want to do, I'm going to divide both sides by negative 60. Oops, that's not what I wanted to do. That's what I wanted to do. So I've got that the cosine of that angle that I'm looking for is equal to negative 12 over negative 60. So when solving for an angle, this is when we use the inverse cosine. So I know that that angle measure, we called it C in the beginning, is equal to the inverse cosine of negative 12 over negative 60. So in my calculator, I'm simply going to do make sure I'm in the right mode here. All right, second cosine negative 12 divided by negative 60, and I get that that angle that I was looking for is about 78 degrees. All right, so we're just going to round it to about 78 degrees to keep things simple for us. And again, what that represented in the problem, the measure there of angle A at island A, so we're going to call this 78 degrees. All right, so now we can use this to find all the other missing angles by using the law of sines. So use the law of cosines first to find one angle, now we'll find the others. So that angle was 78 degrees. And then also the side lengths were 5, 6, and 7, respectively. So this was 5 miles, 6 miles, and 7 miles. All right. So next, use the law of sines to find the measures of angle B and C. All right. So let's just call this little B. Let's call this C. All right. So here we go. Law of sines. This is the easy one. This is where you need an angle and a side across from it, an angle, side across from it, and an angle, and the side across from it. Now, you guys may know that it's unnecessary to use the law of sines for both of them, Because once I find one of these angles, I know that all the angles in the triangle add to 180, and I can figure out